All right, class. Today we're going to look at section 5.2, which talks about dividing monomials. Now, back in chapter 4, we started this journey talking about polynomials, and we learned how to add and we learned how to subtract, and we did a lot with multiplication. And so today is the first day that we're going to look at this idea of dividing, and we're going to look at monomials. So remember, we learned back in chapter 4 that a monomial is one term. All right? Now, the whole thing that we're going to do falls on the premise of this new property we're going to see today. And this new property is the property of quotients. And if you look at it, it says AC divided by BD. Remember, for us, the fraction bar in algebra now means division. And we can bust that up into its parts, and we can say that this is going to be A divided by B times C divided by D. Now, that looks kind of weird when we're only looking at letters, but it's algebra, and what's one of Mrs. Burton's sayings? Well, it's going to be a number thing, and it's going to be a letter thing. So we're going to take care of the numbers, and we're going to reduce the fraction, like we learned in elementary school, and then we're going to look at each letter. Now, as I pull this out here, you're going to see this idea of, I gave restrictions here. Remember, back in chapter 4, we had to worry about restrictions if we had a variable in the denominator. And so, since I've got B and D in the denominator, they're variables in the denominator, we learned back in chapter 4 that I can't have 0 in the denominator or it's undefined. So we have to state a restriction, okay? So A, B, and C are all real numbers, and B or D cannot equal 0. So let's see what that means if we pull out an equation for us to take care of. What does it say if it tells me to simplify that fraction? Well, the first thing I'm going to look at is I'm going to look at the signs. Is that answer going to be a positive answer or a negative answer? That's right. It's going to be a negative answer. Now, let's look at the number part. 16 over 18. What can I reduce that fraction by? If you remember, we called that our GCF. What's the GCF, the greatest common factor of 16 and 18? That's right. Our greatest common factor is 2. So 16 divided by 2 is 8. And in the denominator, we've got 18 divided by 2, which is 9. Now, if I look at that, what do you and I say that the x's would do? Did you notice I got an x in the numerator and an x in the denominator? And we would just say that they cancel out. And then y comes along for the ride. So that's my final answer. Great job. Now, let's see what we can do with a lot of these numbers. All right, so now let's take it a step further, and let's see what happens when I'm dividing bases with exponents. Now, if you look up here at my first problem, let's go ahead and extend that's x to the 5th. If I'm going to extend that x to the 5th, how many x's am I going to have to write? Yeah, 5. 1, 2, 3, 4, 5. And then let's go ahead and extend my x cubed in the denominator. Well, I'm going to have to write 3 x's. Now, we can cancel them out one for one. So this x cancels out that one, and this one cancels out that one, and this one cancels out that one. So what's left? I have 2 x's left in the numerator, so that means my answer is x squared. Now, let's look at the second one. If you notice, I flipped it. I gave you the inverse, and this time I have x cubed, so we're going to write 3 x's in the numerator, divided by x to the 5th, which means I need 5 x's in the denominator, okay? Once again, I can cancel them out one for one. Now look, all the x's in the numerator canceled out. If all the x's in the numerator canceled out, then what is left in the numerator? That's right, a 1, and then we've got x squared. Now, let's look at my third example here. And if we had x cubed divided by x cubed, and we cancel them out one for one, well, everything cancels. If everything cancels, what am I left with? A 1, that's right. Now that we've done that, can you see a rule that we could use to help us to talk about dividing monomials? Did you realize here I can take my exponents and I can subtract them? Okay, 5 minus 3 gives me 2, and the answer was x squared. Now, if I look at the middle one, though, I still subtracted 5 minus 3, and I got 2, and we put the answer back where the bigger exponent was. So here, the 5, the bigger exponent, was in the denominator, so my answer went into the denominator. Now, if we use this idea of subtracting, if I look at the last example, we've got 3 minus 3. Well, 3 minus 3 is 0. Does anybody remember from math past? What is x to the 0 power? Yeah, that's right. Anything to the 0 power is 1. Now, let's see how this is going to relate to us when we have a number thing and a letter thing. So let's look at number 1. If I look at the number part and I look at that fraction, 3/15, how can I reduce that fraction? Yeah, that's right. I'm going to have 1/5. And then let's look at the ends. I've got n to the 7th divided by n cubed. If I subtract those, I get n to the 4th. Is that n to the 4th going to go to the numerator or the denominator? That's right. It's going to go to the numerator because that's where my bigger exponent was. Now, let's look at number 2. And I would look at my signs. I didn't really worry about signs on the first one because they were both positive. But when I look at number 2, we've got a negative divided by a negative. So we know that's going to be a positive answer. If I had 6/15, how can I reduce that fraction? Yeah, once again, my GCF is 3. So we're going to have 2/5. P divided by P, well, we would say they cancel each other out. And then Q squared divided by Q leaves me 1Q. Now, remember on the last slide, we had to give a restriction. Look what they do now in Chapter 5, so we don't have to write a restriction every time. It says, assume that no denominator equals 0. If the directions say that, if the directions say, hey, assume that no denominator equals 0, then we don't have to write a restriction. So in Chapter 5, we get a little bit of a break. We don't have to write restrictions. Now, let's look at number 3. If I look at number 3, a number thing and a letter thing. Well, Mrs. Burton, there really aren't any numbers there, but there really is. Remember, we've got understood ones in front of these guys, but 1 divided by 1 is still 1. What's going to happen with my r's? Yeah, we would say our r's would cancel out. If I look at my s's, I've got s to the 4th divided by s. Remember, this s has an understood 1 as its exponent. So if I subtract those, 4 minus 1 is 3. So I've got s cubed. Where's it going to go? It's going to go in the numerator because of that 4. And then if I look at the t's, we've got t divided by t cubed. And so we're going to subtract. 3 minus 1 is 2. Where's the t going to go? Yeah, that's right. The t has to go down in the denominator because my bigger exponent was in the denominator. Now, when I looked at number 4, when I was getting ready to teach this today, I had a hard time figuring out what my GCF was. All right, the GCF of 39 and 52. Good job. It is 13. So if my GCF is 13, 39 divided by 13 is 3. 52 divided by 13 is 4. Now, what's going to happen with my x's? We've got x cubed over x squared. We subtract, we get x. Where's it going? Numerator. Good job. I've got y squared divided by y. We're going to subtract our exponents and get 1. Where's it going to go? Right in the numerator. And then z doesn't have a partner, so Mrs. Burton would say it comes along for the ride. Now, we're going to get a little technical here on these last 2. If you look at these guys, we've got power to a power. So some of our properties of exponents that we learned back in Chapter 4 are still in play. So the first thing we need to do is take care of that power to a power. So I've got that 4 on the outside is going to be distributed to everybody on the inside. And if you notice when I do that, okay, we're going to get, let me go ahead and just erase all of that. Okay, we're going to get negative 5 to the 4th, all right? And then we're going to get a to the 8th. Remember, I'm going to multiply exponents. Let's do the same thing to the denominator. Well, that 2 is going to go to the negative 5 to the 2, and then we multiply these guys and get a to the 6th. Hey, did you realize that these guys are the same base? If they're the same base, negative 5 inside the parenthesis, then all I have to do is subtract my exponents. So what's 4 minus 2? So we've got negative 5 squared. And then if I look at my a's, it's 8 minus 6, which is a squared. And then hopefully I could get you to say negative 5 squared is 25. Now, let's look at number 6. Once again, I've got power to a power going on. So if it's t, remember we're going to multiply these guys. So 4 times 3 is 12. Now, since it was negative t, when I multiply, I'm going to get t to the 12th. Is that going to be positive t or negative t? Who remembers the rule? Yes, if my exponent is even, then my number will be positive. Let's do the same thing for the denominator. We've got negative t, but we've got 2 squared raised to the 5th power. So that's going to give me t to the 10th. Once again, that's an even exponent, so my number is going to be positive, and now we just subtract our exponents. All right. Now, if you look here at our next slide, they want us to find the missing factor. Now remember, factors means we're multiplying things together. So we've got to figure out what did I multiply negative 7r by to get negative 28r to the 4th, s to the 3rd. Well, if these two written beside each other mean multiplication, what's the inverse of the opposite of multiplication? Division, that's right. So we're going to divide by the factor that we know, negative 7r, to find the missing factor. So let's see what happens here. Negative 28 divided by negative 7 is positive 4. If I look at the r's, I've got r to the 4th divided by r. 4 minus 1 is 3, so we've got r cubed, and s is all alone, coming along for the ride. Now, a good way to check is to multiply them and see if you get negative 28r to the 4th s cubed back. Now, let's look at number 2. Number 2 is a little bit harder. This time I've got 3 terms that I'm trying to multiply together to get this. How am I going to find that missing term? Yeah, I got to multiply these guys together first and see what happens. Do you notice we got some properties of exponents going on, power to a power? So if I simplify this first term, I'm going to get a cubed b cubed. And if I simplify that second term, well, that's going to give me 5 squared, which is 25a squared. And now we're going to multiply these two guys together, and we're going to get 25. A cubed and a squared is a to the 5th. B is going to come along for the ride. And now I can finally divide. We're going to divide by 25a to the 5th b cubed. 75 divided by 25 we know is 3. If I look at the a's, a to the 6th divided by a to the 5th, if I subtract, I get 1. 5b to the 5th divided by b cubed, if I subtract, I get b squared. So far, so good. It's a number thing and it's a letter thing. And that property that we learned, the property of quotients, is very helpful. So now, this is probably the hardest thing for students to understand. They want me to find the greatest common factor of these two terms. Now, we know how to find the greatest common factors of numbers. That's the easy part. But it's algebra. It's a number thing and a letter thing. So Mrs. Burton has broken it down into 3 easy steps for you. So the very first thing we have to do is we have to find the GCF of the numbers. Well, we know how to do that. That's what we learned yesterday. So I need to pull down the coefficients. So I'm going to pull down the 36 and the 24. And Mrs. Burton's going to do double cake like we learned yesterday. So the first prime number is 2. Will 2 go into both of them? Sure will. 2 goes into 36 18 times. 2 goes into 24 12. Okay, will 2 go in there again? Yeah, remember I keep using that same prime number till it doesn't work. So 2 goes into 18 9 times. 2 goes into 12 6. Now 2 won't go into 9 and 6, but 3 will. That's my next prime number. So we've got 3 and 2. So remember, to find the GCF, then I multiply the guys on the outside together. 2 times 2 times 3 is 12. So if I look at the number part, the GCF is 12. Now we've got to look at the letter part. And if I look at the letter part, we've got to find the smaller power of each variable that's a factor to both. Now remember, it's the GCF. That C stands for what? Common factor. So it's got to be common to both. So let's look up here and see what we have. If I look at the x's, we have x squared and we have x. Well, the smallest exponent there is x to the first power, or x. Let's look at the y's. We have y squared and y squared, where they're both the same. So we'll just take out the y squared. And then we've got z to the fifth and z cubed, and the smaller one there is z cubed. And now we just multiply the two parts together. So my GCF is going to be 12x y squared z cubed. Okay, so the number part's easy. It's what we've been doing for a couple of days. The letter part, remember, even though we're looking for the GCF, the greatest common factor, we want the smallest power. And it's got to be common to every term listed. Okay, let's try one more and see what happens. Okay, what's the first thing I do? That's right, the first thing we do is we have to find the GCF of the number part. So we've got 56 and 28 and 42, and I can triplicate. Let's see what happens. What's my first prime number to try? Yeah, 2. All of those are even numbers, so 2 will go into each one of those. 2 goes into 56, 28. 2 goes into 28, 14. 2 goes into 42, 21 times. Okay? Well, 2 won't go into all those. 3 won't go into all those. 5 won't go into all those. My next prime number is 7. 7 goes into 28 4 times. 7 goes into 14 2. 7 goes into 21 3. So we're done. Okay, we can't do anything else. So 2 times 7, the number part is 14. Now we've got to do the letter part. Okay, so let's look up here. I've got r to the fourth, r cubed, and r cubed. Now remember, when we're looking at the letter part, we're going to pull out the letter with the smallest exponent. So we're going to take that r cubed because it's the smallest exponent. Let's look at the s's and see what happens. We've got s cubed, s squared, and s. Which one has the smallest exponent? Yes, s. Now, let's look at q. Q's only in this last term. And remember, for me to find the GCF, it's got to be common to everyone. So this is one time that Q's not going to come along for the ride. And my GCF of these 3 terms then, okay, is 14r cubed s. Great job.